Okay, the screen visible? Screen, is it visible? Please confirm.
Visible.
So we are going to see sequences and series. What we are going to see. Start the chapter. Listen carefully. First of all, what is sequence? Sequence means it's a set with infinite values. Okay, set with infinite values is known as sequence. Now, a sequence can, what is nature? Nature of sequence can be either converging, it can be diverging, or it can be oscillatory. These are three possibilities. Okay, so look at this carefully. Now, how to check convergence of a sequence? What you will do? Suppose you are having limit n tends to infinity un. If it is having finite value, you can say it is convergent. Now, if it tends to infinity, you can say it is divergent. And if there is no unique answer, you can say it oscillates. Okay, these three things we'll see. I'll give an example. I'll give some examples. So I'm giving u1 as 1 by n. Please tell me the nature. Does it converge, diverge, or does it oscillate?
நீ சொன்னபடி பார்த்தா அது வந்து கன்வர்ஜ் தான்.
Converge only. The answer is not diverge. Converge only. What you will do? You will say limit n tends to infinity u1 will be limit n tends to infinity 1 by n equal to 0. So we can say it is convergent. Okay. Now suppose I am telling 2, moving u1 equal to n. Is it convergent or divergent?
Diverge.
Okay. And for oscillation, I'll give an example. Suppose I'm saying u1 is sin n. I can say limit n tends to infinity. u1 will be limit n tends to infinity sin n. Listen carefully. When I go to infinity, the answer can be any answer belonging to -1 to 1. So therefore, it's oscillating. You understand this? Whatever value you put can go to any answer from -1 to 1. Correct? What is the graph of sin x? Look at this. You go to infinity. Exactly where you are going, you don't know it. You're going here, right? You can land up here, you can land up here, you can land up anywhere. We don't know where we'll exactly land up, but we know somewhere you're in -1 to 1 only. So this is an example of oscillatory series sequence. Any doubt in this? Can I proceed to next concept?
Like oscillatory, convergent, divergent இதெல்லாம் வந்து n tending to infinity வச்சுதான் சொல்லுவீங்களா?
Yes, with n tending to infinity only you should say. This is sequence, not series. Not come to series. With n tending to infinity only you can tell.
Okay.
Okay. Now sequence. Listen carefully. Now we will see series. Listen carefully. There's a difference between sequence and series. Now we'll see series. What is series? What is the difference between sequence and series? Series, now what you are doing is you are doing summation of terms of sequence. Summation of terms of sequence. That's the difference between sequence and series. Now, if the sum is sum of n terms where n tends to infinity. Now for this you will check convergence, divergence, and oscillatory. Okay, oscillatory will now it will come. Yeah, it can come. With this you will check convergence, divergence, or oscillatory. I'll give an example to understand. First example, check if sigma u1 is. Now check nature of sigma u1. I'll write like this. Check nature of sigma u1 where u1 equal to n. Now how to do this question carefully? Same question I gave here, but This is a different question. The same U1 I gave, but this is a different question altogether. See, this question, what you did, this question, you just check last term on that's it. You're checking only last term. But now you need to do summation and then check last term. So what is sigma U1? Sigma, what is sigma n? N into n plus 1 by 2, correct? Sum of natural numbers. Now you are doing limit n tends to infinity, sigma U1. What is it? Limit n tends to infinity, n into n plus 1 by 2. This will be what? It will tend to infinity. So I can say sigma U1 is divergent. Any doubt on this?
No, no doubt.
See, here I said U1 is divergent. U1 is divergent. Here U1 is convergent. But here I am saying sigma U1 is divergent. Sigma U1 I am talking about. That is the difference I am talking about sequences and series. Okay. Now listen carefully. Now we'll do another question. We'll make an answer. I am giving U1 as 1 by n. Now check nature of sigma U1. Tell me the answer.
Answer divergent ன்னு தெரியும்.
You know the answer is divergent, but how is it divergent? I want to know. Everyone knows the answer is divergent.
தெரியாது.
Good. No problem. Look at this. Okay. What you need to do? First you have U1. First you need to find what is sigma U1. Sigma 1 by n to calculate. Now tell me, can you calculate this possible? Is it possible to get expression for sigma this n 1 by n is possible? You have any general formula? I think here you have general formula. Do you have any formula? This is nothing. This is harmonic series. Sum of harmonic series is actually. There is no such formula, correct? Is it possible to know? Can you get an expression for sigma 1 by n?
No.
Not possible.
Like standard formula எதுவுமே கிடையாது.
We don't have standard formula. No, we don't have any standard formula to get the expression. So that is why another for every question. See, for this question, what you could have done, you just had the expression, you did summation, then you took limit. But for every question, it's not possible. See, what is the actual rule? Actual rule is you have U1, you will find sigma U1, and then you will take limit n tends to infinity sigma n, correct? But this step, this is not always possible. That is why we have so many theorems. Understand? That is why this many theorems are there. If for every sequence, if we know how to find this sigma U1, then we can find it. Just take limit to infinity. No theorem, nothing. But that is not possible. That is only we are taking theorem. So using some theorem, we can say sigma 1 by n is divergent. Understand? This you should understand. Difference between, see, sigma 1 by n is divergent, but 1 by n is convergent. Difference. Last term is converging, but the series sum of terms till last term is not converging. Understand the difference? Tell me, yes or no? Just 1 minute, I'll be back. Yeah, can I proceed, Pa? Tell me who are in the class. Can I proceed? Okay. So for that only we have so many theorems. So what I'll do, I'll just list down all the theorems. All theorems I list down. Okay. What are theorems? We'll see. I'll tell last term test. Second, I'll say comparison test form 1 and 2. Third, I'll say, what is the next test? Third, what else you have?
D'Alembert ratio test.
D'Alembert ratio test. And fourth, you have logarithmic test. Fifth, you have Rabi's test. I'm known for the spelling. Rabi's test here. Sixth, you have Cauchy's root test. Seventh, you have Cauchy's integral test. Here, this is that one, no? No, the test. I just write it here. So there are 7 tests you are having. Cauchy's. So with these tests, see what are the use of these tests? That one I tell me. Write like this.
Standard form இல்லாத sigma un க்கு யூஸ் பண்ணுவோம்.
Exactly. When sigma un cannot be evaluated, these tests help to check nature of sequences in using different methods, using alternate methods. You know, sigma un cannot be evaluated. These tests are used to check the nature of sequences, and these are for positive term sequences only. You're having all terms are positive. So for these, we are having all these tests. Okay.